Hello and welcome to another video. In this video we're going to be doing insert delete get random O of 1, and in the problem you have to implement the randomized set class which initializes the randomized set. You can insert, you can remove, and you can get random, and you basically have to do all of these in O of 1. So insert inserts the value into it if it's not there, and write true, false if it's already in there, and then you want to try to remove, return true if you could, or false if it's not in there. And then get random just gets a random item out of here. And each element must have the same probability. So kind of the problem with this thing is, ideally you'd want to use a set for this, right? So you'd want to just have like a set of values. So if you can put in like value 1, 2, 3, you can have O of 1 lookups, O of 1 removes, and so on. But the problem is this get random part. So this get random doesn't let you do that because you can't get a random element from a set in O of 1. You need an array. So not only do you need to have these items, like let's say you have these numbers like 1, 2, 3, you need to have an array available with these items as well to be able to do get random in O of 1. And the problem is, let's say you do have both of these, but then you want to remove from the middle of the array. You can't remove from the middle array in O of 1. So it's kind of like, okay, how do I do 1? How do I do this? I need an array. How do I do this? I need a set, but I also need to have the array, and I need to be able to remove from that array in O of 1. So that's kind of like our problem is we need to have a set or like a dictionary or something and an array, and we need to be able to remove from an array in O of 1. So you can't remove from the middle of an array, but where can you remove from an array in O of 1, right? Only one place. You can remove from the end. So what we can do is we can have some stuff. So let's say we do have like a set, right? So we'll have a set, let's say a set, or in this case, we actually want a hash map because we want to know where, like we need to map our element to the array. So we need to have a location. So let's kind of like walk through an example of this. Let's say we just put in 1, 2, 3, 4. So basically what will happen here is we'll put in 1 and then we'll have an array. And so we'll put in 1 into index 0, then we'll say like 1 is at index 0. Then we'll put 2 in at index 1, then we'll say 2 is at index 1, right? Every time you do an insert, you basically just check, is it in your dictionary? And if it isn't, put it into the array and write down its location. So let's say we put in 3 at index 2, so on, and 4 at index 3. And let's say we try to now remove 2, right? We want to remove 2. So we can't remove from here, but what we can do is we can always, whatever we're trying to remove, we can always just swap it with the last element and also do that in our dictionary, right? So here, we can simply swap it with a 4. So we can put a 2 here and a 4 here. So we swap. Then we also need to actually update this, right? So 4 is now at location 1 and 2 is at location 3. Then we can easily just remove the 2, right? So if we wanted to remove it, we can do that now, and we can just pop it from the dictionary, and that's O of 1. That's kind of like the crux of this problem is you basically need to know I need to remove from the end of the array. And in order to remove from the end of the array, I just need to put my element in the end of the array and then update this dictionary and get rid of the item in here and in here. And then the random part is just easy. So in Python, you can just call random.choice and it will give you a random item from an array in O of 1. In other programs, you can do something similar, right? Just get like a random index or something and then use an index. That's the whole point, because you can't index a set, but you can index an array. You might be able to do something else, possibly, like there might be some kind of solution, which it makes some sense to me, where you have all of your keys, and then you just get like a random, actually, no, that wouldn't work, right? Because you can't index into keys, so you can't just say like, let me get a random index. That's why you would have to have an array. And so that's how we're going to code it up. We're going to have an array, and we're going to have a hash map. And we're just going to, anytime we remove, we will just take whatever we want and put it in the end and swap it with that item. And then we can always remove from the end. So let's code it up. So we're going to have two things, right? So we'll have self.items in an array and self.locations is going to be a hash map. So the insert is pretty straightforward. We just check if the value is in locations, we can just return false. So if value in self.locations, we can just return false because it's already in here. So that's why it's also nice to have the hash map or the set. Otherwise, we just do self.items.append val, and we write down that index into location. So we say self.locations val equals length of self.items minus 1, right? We just write down where we wrote it. So the remove is going to be the, let's write this one first. So this one is simply just return random.choice of self.items. So pretty easy, right? We just basically just say this function will just give you a random item in array in of1. So this is kind of like the tricky one. So first we check, is it in our dictionary? If it's not, there's nothing to remove. So we can copy this in. So now it's not going to be not in. Okay. Now we have to get what we're actually removing, right? And where it is in the array. So we can call this like toRemove equals self.locations val. So this is where in the array our item is. Now we also need another thing, right? So we need to, like, if we go back and look at this picture, when we swap the two values, when we swap the 4 and the 2, we need to know what value is here, but also what value is at the very end, right? So that's the other one. We need to get both of those, and then we need to swap their locations in this dictionary and also in the array. So we can call this like last or something, last item maybe, equals self.items minus 1. So now that we have that, we basically can write, like now that we have both of these, now we can put toRemove in the end there, right? So we can say, actually what we really want to do is, before we do that, what we really want to do is we want to update the location in the hash map. So for example, if we had 1, 2, 4, 3, 4, so we're removing 2, but we need to update 4 to be this new index, right? So that's what we're going to do next. So we're going to say self.locations last item is going to be this location over here, right? toRemove. That's where it's going to go. Now we need to actually do the swap. So that one's pretty straightforward. We just swap the two locations. So we can say self.items. And remember, it's over here, right? So toRemove is going to be the index. And it's just going to be the very last item, right? So we can just say this is going to be self.items at this. So we actually need to actually manually take the two things in the array and swap those. So we can do it like this, and self.items toRemove. So now that we swap those, what we need to do is we can pop from the array, and we need to get rid of this like toRemove thing, right? So what we need to do is we need to get rid of this. So actually, we don't need to get rid of this toRemove. What we do need to do is we need to get rid of self-locations value, right? So wherever value was, we can just get rid of that. So we want to say self.locations.pop value, right? Whatever the value we just removed, let's get rid of that from the dictionary and return true. And we can run this. And let's take a look. Okay, so we got a wrong answer. So let's double check this. Self-items append val, this part's fine. If value not in, this part's fine. So let's just double check the logic. So here we are getting the index of value, of the value that we're removing. And then we're getting the actual thing that's the last item. So self.locations last item is this, that's fine. And this one is fine as well, I believe. So let's actually look at what we're getting wrong. So if we insert 1, we're getting false. Okay, so I think we're just not returning. Yeah, so we need to return true here. So we're missing that for sure. And let's see if we're missing anything else. Yeah, it looks like it's good. Hopefully. Okay, and it's pretty efficient. So yeah, now obviously the time and space complexity is going to be pretty easy. So the time, obviously all of these are O of 1 now, right? Like this is O of 1. In this remove, we just swap 2 items and then pop, and this is O of 1 as well. So these are all O of 1 because that's what it needs to be. And for the space, it's straightforward as well, just like O of n, like however many items you put in here. So yeah, not too much for like complexity analysis, but yeah. And I'm guessing this is also a pretty popular interview problem because it doesn't ask for any advanced algorithms, but it's just kind of like common sense. So if we actually take a look, as you can see, it is. I was kind of sure it would be. So yeah, very popular interview problem. So definitely something you need to recognize. Just like, how do I remove from an array in O1? I need to make sure my item's in the back. How do I get my item in the back? I can just always put it in the back. And yeah, I think that's going to be all for this one. So hopefully you like this one. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.